about systems. We're not going to talk about any yet that have the words wrapped around them. If you're doing your ALEKS, you might have seen those already. So, anytime you get to a point in ALEKS that we haven't covered the topic yet, slow down, stop, and you can wait for us. And eventually I should touch upon everything that's going on in ALEKS, I hope. So we're going to talk about systems and some of the rules for systems. I'm going to show you what to look for and how to deal with it. So let's take a look at this first one. A system of equations, there's really kind of three methods you can use to solve them. One of the methods is substitution. Another one you might remember hearing of is elimination. Another one is to graph it and see where they overlap. What is their point of intersection? So I'm going to show you kind of some different methods depending on the problem. Let's take a look at this first one. It says graph the system and then write its solution. So you'll notice that over here we have a piece of graph paper. So we're going to put it right here. So one way to solve a system is to graph it. So the system's solution is where do they overlap. So think about what we have. If we have two lines, they might overlap at one individual point. So that would be a one solution type system. You might have two lines where the lines overlap. So you draw one and you go to draw the other and it tends to be the same line. That would be an infinite number of solutions. That's what they're talking about here. And then another alternative, if you go to graph a line and the two lines are parallel, that's what would happen if there's no solution. Okay, so let me kind of go over that one more time. So if they cross in one particular spot, that's one solution. If they, sorry, my graph paper's so bad. If they have infinitely many solutions, you would go to graph one line, and then the second line would be a perfect overlap. And then finally, no solution would be when you graph one line and you graph the next line and they are parallel. Okay, so there's really graphically, if you look at a system of linear equation, there's really three options. They'll cross at a point and your answer would be, like the 0.27 or whatever the case may be. They overlap, so there's infinitely many points that they overlap, or there's no solution. It's meaning that they're parallel, they never touch. Okay, so when we go to graph these equations here, so I'm going to write them over here so we have them. Just a minute, let me write that. X plus 3y equals 1. And y equals negative 2x plus 2. So let's look at the strategies. You know how to graph a line. You may use whatever technique you want. So if you know how to graph a line with the slope and the intercept, great. If you know how to graph a line by plugging in some points, great. I don't care how you do it. Go for it. You do your thing. Now, the problem is when we are trying to find the solution of overlap by graphing, we have to be careful that we try to make that line as straight as possible. And you haven't seen me graph a lot of things yet, but you already probably get this. I can't graph a straight line to save my life, but I'll do my best. And you're going to have to really be careful when you graph it. Okay, so let's do our first one here. Now, I think this first one is a really good candidate because this one here is in standard form to use my 0, 0 chart. That 0, 0 chart is just a way to quickly find the x and y intercepts. That's 2 points on our graph. It's where we hit the x and y axis, all that great stuff. Okay. So if I plug in 0 for my x, So that would be this one right here. So if 0 is my x, that term's going to go away. And I'm going to get 3y equals 1 or y equals 1/3. Okay. If I plug in 0 for my y, this term's going to go away. And you just immediately get that x equals 1. So check my graph paper. You'll notice my graph paper is counting by ones this way, 1, 2, 3, 4, 5, and ones this way, 1, 2, 3, 4, 5. So it's perfectly counting by ones. Always check that. I can't guarantee the graph paper I put in there is going to count by ones. Most of it I think will. And let's graph it. So here's where graphing that 1/3, we're going to have to kind of guesstimate. So on our x-axis, we hit at 1. But on our y-axis, we only hit at 1/3. So we're going to have to kind of guess. And then graph your line. Okay. Now you want to try to make it as straight as possible because we're going to be looking for where those things overlap, okay? Okay, so now we have our green line. We have this x plus 3y equals 1. Let's do my second line. My second line is a good candidate, I believe, for slope and the y-intercept are kind of just showing up. It's in slope-intercept form. So the slope is -2. I'm going to put that as -2/1, so you have that rise and run. Okay, so you have that rise and run. And my y-intercept is the point 0, 2. So to graph that one, we are going to go to 0, 2. We're going to count down 2 over 1. Ooh, it hits it perfectly. Down 2 over 1. That's great. If it doesn't hit it right off the bat, make sure you stretch that line out until they do hit, because then you'll get a nice intersection if they happen to intersect. Okay. And if you were doing this, say, on a quiz or a test, if you had to solve it by graphing, you should label the point of intersection. So that is the point 1, 0. So the answer is 1, 0. So the point of intersection is 1, 0. The answer is 1, 0. So that's what they're looking for that problem. Does anybody have any questions on how to graph a system to find its solution? Now, here's the problem about graphing a system. When you graph a system, unless you are perfectly like straight, unless you are perfectly careful, if they cross at like a fractional point, you're going to have to guesstimate. That's where the power of algebra becomes so helpful, because if it's an algebra type thing, it's more helpful. Okay. So let's start practicing some of the algebra. Okay. So a solution to a system of equation is a point that works everywhere. Okay. So if we say, is it a solution, and you're picking yes and no, let's show you what you're going to do. Let me write down my equations. I'm going to write them left and right so I can just check them together. Okay, so the first one I'm going to try is 1, -7. So every place I see an x, put a 1. Every place I see a y, put a -7. So we get 9 times 1 plus 2 times -7. Now, when we plug it into that one, we better get an answer of -5, That's what makes it work in that particular equation. So I'm only going to do one at a time, because if I don't get -5, I don't have to check the other one and waste my time. Okay, so I get 9 minus 14, which is -5. So that makes me want to try now the other one, because it has to work in both. So now let's try the other one. So again, I'm plugging in 1 for x and -7 for y. So we're going to get 2 times 1 minus 3 times -7. Now this time, I better equal -8. Well, I'm going to get 2 plus 21. There's no negatives there to be found. How am I going to equal -8? It's impossible. So that does not equal -8. So that's a no. Everybody see what I'm doing so far? Makes sense? Let's keep doing. Let's do it again. So now we're going to plug in -2, 1. So 9 times -2 plus 2 times 1. Does that equal -5? Well, we get -18 plus 2. That's a no. You don't have to check both. If one fails, you're done. -18 plus 2 is -16, not -5. So that's a no. So just throw it out. You don't need it. Now let's try 5, 6. Now I'm going to try it in the first one. I get 9 times 5 plus 2 times 6. Does that equal -5? Well, there's no negatives to be found. How am I going to get -5? You can check. That is 45 plus 12, which is a no. We got one more to check. One more to check. Last one we're going to check is 0, -4. So we're going to get 9 times 0 plus 2 times -4, which is -8. That is a no. Why they gave us so many no's, I do not know. But that's how you would check them. They have to work in both in order for us to say yes or no. Did I mess any up? Is that okay? Does that look right? You got all those?
I did it all in my head.
Yeah, I'm like, wait a minute. You'd think they'd at least pick one that works. Anyway, so that's how you check. They have to work in both. If they don't work in both, put no. If they work in both, that's your yes. Okay? Any questions about that one? So now let's look at the algebra of things. So you might recall there is pretty much 3 ways to solve a system. Graph it. That has some problems because of the fact we might, have a fractional point you're crossing over, and what is that fraction? So the algebra is where you really want to go if you can. Now, if you graph them in Desmos and you check, hit the point, it's going to give you an exact value. But when you graph it, you got to be careful. And that's a way to check your work. But let's talk about 2 methods algebraically that we can use: substitution and elimination. The first one, let's talk about substitution. They want us to use substitution here. And the way that I really kind of know that substitution is kind of the route you would take anyway. Do you see how this equation says that y equals something? Y equals 2x minus 9. When one of your equations is like that, that is a perfect substitution type problem, because what we're going to do is we're going to take that information and we're going to plug it into the other equation. We're going to substitute it in where we see y. We know y is equal to 2x minus 9. So I'm going to write the other equation out. I'm going to put a little parenthesis where the y is sitting. And that's where I get to put what y is equal to. Y is equal to 2x minus 9. Now, you might notice at this point, we only have x's. That's great. That's telling us we are doing what we should be doing. Okay, so now remember those equations we solved in the first part. In the first part, we solved these linear type equations. So now we get to solve this, right? So now it only has x's in it, so solve for x. So we're going to distribute. We get 3x plus 4x minus 18 equals 10. Simplify both sides as much as you possibly can. 7x minus 18 equals 10. Get the x's by themselves. 7x equals 28. So x equals 4. Now, it is a point of intersection. So we have only found the x, but we know something great. We know that y equals 2x minus 9. So if we stick our 4 value right there, then we've got it. So you should always write your answer as an ordered pair if they intersect. So y is going to equal 2 times 4 minus 9, which is 8 minus 9, or negative 1. So you should write your answer as an ordered pair. Our answer would be 4, negative 1. So if one of your equations say x equals or y equals, substitution is a really good tool to use. Okay? You're not done until you've found both variables. Do we have any questions about our substitution example? Okay. Now, when the x's and y's look like this one, I would suggest using something called elimination. Elimination, we want to eliminate one of the variables from the problem. Okay, so how do we do that? Here's what to look for. To use elimination, some things have to be ready in your problem. We have to have the x's lined up. We have to have the y's lined up. We have to have the equals lined up, and we have to have the numbers lined up. If those things are not in the correct order, you are allowed to switch things around so that your x's come first, then your y's come first, then your equal to, and then your number. Okay, so you're allowed to rearrange. You know how to rearrange an equation. You can do that. So everything's in the right order. And so then this is what we look for. We look for a number that either the x's can, those coefficients can divide into, or the y's. Okay, so let's think of what numbers we have to choose from. For a number like 3 and 2, what's a number that can both go into? Just multiply 3 times 2, 6. So we could turn those into 6's. If we use the y's, 8 and 7 don't have anything really in common, so just do 8 times 7, 56. We could use those and change them into 56. One's not better than the other. Sometimes one might be a little easier than the other. I tend to go with something that makes it a little smaller. So I will tend to go with the 6 and not the 56. If you pick the 56, you're okay. It's correct. You're just going to have larger numbers to deal with than maybe what I would deal with. Okay. So how do we do this? Well, we want to eliminate whichever variable we choose. And to do that, we want one to be the positive version, one to be the negative version with the same coefficient. So I've decided to use 6, and I'm going to change these into 6's, and I'm going to do it so that one is a positive and one is a negative. Now, what's great is one's already a positive, one's already a negative, so that's great. Okay, so all you're going to do is I'm going to multiply all of this equation times 2 and all of this equation times 3, so that you kind of flip-flop it, you know? Okay, so let me show you the top equation, what I get. In the top equation, I get 6x, excuse me, minus 16y equals negative 34. And now I'm going to multiply the bottom equation by 3. I'm going to get negative 6x plus 21y equals 54. Does my math seem to be reasonable? Did I get everything right? Okay. I'm just checking because I make stupid mistakes sometimes. Okay, so if all is right with the world, what we should see here is that these should be opposites because we want them to go out of the problem, so we only have to deal with one of our variables, our y's. So you'll notice those are perfect opposites. So when I add the two equations together, the x's have been eliminated. That's exactly what we wanted to happen. Negative 16 plus 21 is positive 5y's. Negative 34 plus 54 is positive 20. Divide off the 5, and we have found our y. Now, elimination is not as nice for this final step. Remember how our last one, it said y equals, you know, that, and it was great. here we have we don't have an equation that's super nice to plug back into. So you pick whatever you want, okay? I am going to plug into this top one just because there's no real rhyme or reason. And when I do that, I get 3x minus 8 times the y I just found of 4 equals negative 17. So all I've done is I've taken the y. I either have to plug it into my top equation or my bottom equation. Doesn't matter which. You pick, you decide. I think the bottom one just is a little bit yuckier, so I just decided, hey, go for the top. I get 3x minus 32 equals negative 17, which gives me 3x equals 15, because if you add 32 to negative 17, you get 15. So x is 5. So your solution is 5, 4. Now let's talk about some things that could happen when you're solving these systems. If both the x's and y's go away and all you have are numbers left, if the numbers say 0 equals 0, it's a legit solution. Those are overlapping lines, so it would be infinitely many. If you get 0 equals 7, is that a legit thing? Can 0 equal 7? No, of course not. So that would be the one to indicate that it's no solution. So if you try this elimination or substitution and you get a true statement without x's or y's that say like 0 equals 0, you say infinitely many solutions. If you get 7 equals 0, it's no solution. It doesn't work. Just wanted you to know that. Okay, let's do one more with elimination. Do we have any questions about that one before I move on? Are we okay to move on? Okay, let's do one more, and then you're ready to try some. Okay, here elimination is so makes sense because what do you notice about our y's? They're already opposites. So this is a great one. I love when this happens. You know, our x's, y's, equals, and numbers are all lined up, and you can just add them up because the y's are already opposites. Perfect. So now we get 8x equals 16. Divide by 8, you got it. X is 2. Now remember, you're not done because we always want an ordered pair when solving a system. What is the point at which they crossed? And so you can plug into either one. I'm going to use the top equation just for the heck of it. So if I use this top equation here, I'm going to get 5x plus 2 times our, no, I'm not. Wait a second. I was doing good too. I was going to put it into the wrong spot. 5 times our x value of 2 plus 2y equals negative 4. So take out your x value, plug in a value of 2. We get 10 plus 2y equals negative 4. Now you're going to move that 10 over first before you deal with the 2. So you're going to subtract 10 from both sides. We get 2y equals negative 14. So y equals negative 7. So your answer should be written as an ordered pair. So that is the pair 2, negative 7. Oh, yeah. I mean, a great thing about this is you can check the algebra a few different ways. If you plug this point into both equations, you should get a true statement. You could also plug both equations into Desmos and check, did I really hit the point to negative 7? Okay, we good? Okay. So now you're ready to try these. The first two, I would like you to solve by graphing. These ones you're going to use substitution. See how like this one says y equals and this one says y equals. You may have to rearrange these two. And then these ones are elimination. Okay. And then tomorrow we are going to talk about some word problems that end up being like this, but we'll show you how to interpret those word problems. So for the rest of class, work on these 10 problems, okay?